the second video about points of concurrency. Just recall that the vocab that we talked about yesterday, concurrent means when three or more lines, these lines can be rays or segments that intersect at one point, and then when these lines intersect, that means that they are going to be concurrent. The point of concurrency, we talked about the circumcenter and the end center yesterday. Today we're going to talk about two more, and this is the point where the three lines are going to intersect. This is section 3 on your worksheet. It's actually on the back. We're going to be talking about medians of a triangle. The first question is, what is a median? Well, a median is the line segment that joins the vertex to the midpoint of the opposite side. So for example, if you have a triangle, you're going to find the midpoint of the side, and then you're going to connect the vertex that's opposite of that point to the midpoint, and that is going to create your median. Your median does not have to be perpendicular because this is not a perpendicular bisector like we talked about yesterday. A median is just going to go from the vertex of the opposite side to the midpoint. Where's the location? If you were to move that triangle around, if it was a right triangle, an acute triangle, or an obtuse, that location or the centroid is always going to be inside of your triangle. The centroid is with an intersection of those three medians. So it says that below, but this is also going to say centroid. What are some important facts? We're actually going to be doing an investigation about this. The distance from the centroid to the vertex. So this larger distance right here from the vertex to the centroid, that's going to be 2/3 the whole median that you can draw. If you need to pause the video, please feel free to do so. Section 4 talks about altitudes of a triangle. Again, what is an altitude? An altitude is a line segment array that is perpendicular to the opposite side. The one thing that is a lot of kids will struggle with is they get the perpendicular bisector and an altitude mixed up. An altitude does not have to go through the midpoint. We're going to see an example in just a minute. When we talked about perpendicular bisectors had to go through the midpoint of that side, and it had to go through the vertex of the opposite side. Now, when we talk about an altitude does not have to go through that vertex. It does not have to go through this. I'm sorry, I said that wrong. The altitude does not have to go through the midpoint. It just has to go through the vertex. So that's the difference between your perpendicular bisector and your altitude. So where's the location? If you were to have an acute triangle, so no matter what kind of acute triangle you drew, that altitude is going to be inside the triangle somewhere. As long as it goes to the vertex of the triangle and it does not have to go through the midpoint. So it has to go through the opposite side somewhere. When you have a right triangle, so if you were to transform that into a right triangle, you are going to notice that this dotted line in the acute triangle is now going to shift to the left. That is just going to be a vertical leg of your triangle. That's where your altitude is for a right triangle. And when you have an obtuse triangle, so if you were to drag that top vertex all the way over to create an obtuse triangle, that you'll notice that that altitude has now shifted to the left as well, and it is now outside of the triangle. If we were to extend the base of this triangle right here to get that dotted line, that's where it's going to be perpendicular at. So the location of your point of concurrency is now going to be inside your triangle, the vertical leg if it's a right, and it's going to be outside of the triangle if it's obtuse. This intersection of the three altitudes of the triangle is called the orthocenter. And then what are the important facts that I must know? We're just going to skip this for now. We'll come back to this. So we are going to try to remember all these. You're going to be responsible for knowing all 4 of these names and what they associate with, if it's a perpendicular bisector, angle bisector, median, or altitude. The 3 things, there's 3 ways that you can remember this. When you think of the word angle bisector, where would that angle bisector be located? Well, that angle bisector is in the middle of your your angle. So that's why it's called in the center or in center. For a median, when you think of the median, most people would say, well, it's the center of the road. That is correct. Most of the time, the roads will have a median or the center of the road. Thus, that's why we say the centroid. It even kind of looks like center of the road. And then the last hint that I can give you is altitude. When you think of altitude, you think of a plane. When you're flying in your plane, that means you're really, really high. So if you're flying over mountains, the mountains are really high. What else is really high? Well, the orbit, or Saturn. Okay, so when you think of orbit, and when you think of altitude, you think that both are really high. Well, since they're both really high, that's why we can say it's the orthocenter. I have not come up with an easy ways to help you remember circumcenter and perpendicular bisector. If you can think of one, please feel free to share. I'm always looking for new ideas. That is the end of this video. Please bring these notes tomorrow for class.